second quiz, May 10. It's going to be 2-hour quiz. So you can prepare 2 pages of cheating sheet. And no class. And quiz covers whatever the topics that we studied after that last quiz until today. 지난번 퀴즈 본 다음부터 오늘까지. Topic. We covered after the last quiz to the subject we are learning today. So all the quiz is the same pattern. Whatever that subject after the previous quiz until the whatever class before the quiz. And final exam covers from beginning to end. 그 퀴즈는 항상 마지막 퀴즈 다음부터 가장 크게 배우는 것까지. 주말 시험은 전체. So we are going to learn the basics of calculus. The two things E is a Laplace number. .718, etc., etc., etc. And I think previous we covered the logarithm BSD log x, right? This is the last topic we covered. Right? So we are going to cover several more derivatives that you probably have memorized. So when fx is exponential x, and you know the answer when you take a derivative of exponential x, the same as exponential x, right? That you memorized. But since we are going to derive the derivative from the first principle, exponential x plus delta minus exponential x. So we can put exponential x a common factor, exponential delta minus 1. E, Lyapunov number E. But Lyapunov number E is actually, since E, right, for small delta, what is exponential e to the delta? E to the delta is 1 plus delta, 1 over delta, delta, right? So this is actually 1 plus delta, delta over delta, so 1 plus delta. So e to the delta minus 1 is actually delta. So if we divide everything by delta, what do you get? Delta fx plus delta minus fx is exponential x times delta divided by delta exponential x, right? So one can say that dxt exponential x is exponential x. Any questions about that? So I found that today's COVID number is 20,000. And 코로나 확진자가 2만요 today. So otherwise you should wear a mask for your own safety. It looks like the COVID number of COVID cases is increasing. So maybe for the better for your own health to wear a mask. So actually for me, giving a lecture with a mask is a bit difficult. But yeah, for your own safety, I'm wearing mask. And also for my own safety. A bit more difficult example is a to the x. So anybody remembers the derivative formula? It's probably in 수학의 정석. A to the x log x, right? Log a. Probably have memorized. But we can actually derive this as well. It's not very difficult. But we have to be able to notice that a can be represented as exponential log a. So A is same as exponential log A. You can actually check. Take the log. So when I say log, it's same as log base E. Log A is log e to the log A is log A log E, but this is 1, right? So we can always say any number A can be exponential log A. So as long as you remember this very simple formula, then A to the x is exponential log A to the x, exponential x log A. That is fx. So f x plus delta minus fx is exponential x plus delta log A minus exponential x log A. So we can factor with the x log A common factor. We can say exponential x log A delta log A minus 1. Of course, we know that 1 plus delta, 1 over delta is E, right? But actually, we can also extend this 1 plus delta alpha, 1 over delta alpha, also E, right? And delta alpha goes to 0. So we have 1 plus delta log A, 1 over delta log A is also equal to E, right? When delta goes to 0, delta log A goes to 0, because therefore e to the delta log A is 1 plus delta log A, 1 over delta log A to the delta log A, 1 plus delta log A. Or e to the delta log A minus 1 is delta log A. Therefore, fx plus delta minus fx is equal to the x log A delta log A. Therefore, delta over x plus delta minus fx is x log a delta log a. And this delta cancels each other, and it becomes x log a something. Sorry. E to the x log a. E to the x log a. E to the x log a, which is a to the x log a. Sometimes I'm going to use log a, sometimes ln a, same. It's natural log. Unless otherwise specifically said, log means natural log. Sometimes I just use log, sometimes just ln. So log e ln. So we have covered derivative of polynomial, and inverse polynomial, 1 over x, etc., and natural log, exponential function, and general exponential function, a to the x. So which function is left over? Trigonometry. Give you time to copy. So I'll go as slowly as possible, but if you have any questions, it's about the time to raise the question. Probably you have covered this topic in your high school days and maybe freshman, not right calculus. But still, some of you may not be familiar with or not very familiar with the derivative. So I'm going to spend some time. Trigonometric function. For the least amount of information, I assume that you know the addition theorem, sin x plus y. So I'm not covering that this semester. So sin x plus y, sin x, cosine x, sin y,
cosine x plus y is cosine x cosine y minus sine x sine y. Okay. Let's just assume that you know this addition property, additional theorem. Probably you have done in your high school, right? Let's start with this knowledge. So sine x plus delta is sine x cosine delta sine delta cosine x. So the easiest way of approximating sine is, let's assume with the circle with the unit radius. And differential angle delta, then this is delta, right? This is called arc. So if we have a magnifier, then this will look like this. This is arc, and this is short. This is also delta. Short. Short arc. So when delta is sufficiently small, the arc length and shoulder length should be the same. Then this is 1 plus delta square. So sine delta is approximately 1 plus delta square over delta. And cosine delta is approximately 1 plus delta square over 1. For delta is small. That's actually what Newton did in 1645. So we have the one interesting limit. When delta over the sine delta is actually 1 over square root over delta square, it goes to 1 as delta goes to 0, right? How about cosine delta? Cosine delta one plus delta square over 1 is approximately 1 plus delta square over 2, right? So cosine delta minus 1 is 1 plus delta square over 2 minus 1 1 plus delta square over 2 minus delta square over 2. So if we divide by delta, cosine delta minus 1 becomes minus delta over 2, 1 plus delta square over 2 goes to 0. These are the limits that we need to know. So, using this property, you can calculate in fx is, maybe you need time to copy, right?
Any questions about approximate sine delta and cosine delta using a software? No question? Okay. That's actually what Newton did about 400 years ago. Okay. So sine x plus delta minus sine x is sine x cosine delta plus cosine delta sine x. No. Cosine x sine delta, right? Minus sine x. So this is sine x cosine delta minus 1 plus cosine x sine delta. So if we divide by everything by delta, what do you get? Delta sine x plus delta minus sine x is sine x delta over cosine delta minus 1 plus cosine x delta over sine delta. So when delta goes to 0, we already obtained that this goes to 0, right? This goes to 1. So it becomes cosine x. So when you differentiate the sine x, you get cosine x. Probably you have memorized it in high school, right? But now you know how to derive it. So still you need to memorize it afterwards. But there's a big difference. Just memorizing it and knowing the fact and memorize it. There are two different things. How about cosine? Cosine x. Cosine x plus delta. You can just use the cosine addition theorem. Cosine x cosine delta minus sine x sine delta. So f x plus delta minus fx is cosine x cosine delta minus sine x sine delta minus cosine x. Delta f x plus delta minus fx sine. So this goes to again 0, this goes to 1. So this becomes minus sine x as delta goes to 0. So dxt
sin x minus sin x. So we covered polynomial, logarithmic, exponential, trigonometric. What else? Inverse functions, right? Copy still? You haven't any time for that? Inverse function. Say y is sine inverse x or x is sine y. So delta y over delta x. So actually you can say delta x over delta y. So dy dx is actually cosine y, right? This is square root of 1 minus sine square x, sine square y, square root of x square. So dx dy is actually 1 over dx dy square root of 1 minus x square. Oh, this is different section. Oh. So actually, derivative of inverse is very easy. You just take the inverse of delta x delta y. This is possible because derivative is basically the ratio of the change of function divided by the ratio of x, right? So you can make an inverse. Now, product of functions, when fx gx times hx. So f x plus delta minus f of x divided by delta is what? Delta 3x plus delta hx plus delta minus 3x hx, right? In mathematics, in many cases, you can achieve there is a you can do many things by doing nothing. This is about time to introduce my favorite problem. In mathematics, you can do many things without doing nothing. So in mathematics, doing nothing means you can add zero. So there are two kinds of doing nothing. Add zero or multiply by 1. So in mathematics, actually, if you want to show something, you just do nothing. Do nothing means actually just add zero or multiply by 1. So let's try to see what this case. So I'm going to do nothing. By 3x plus delta by subtracting and adding the same thing. Right? Here, I subtract gx plus delta and then add it the same term, gx plus delta. So basically they are zero, right? But we can combine them together as so this is basically dxgj, right? And this is basically dx dh. So it becomes dx dgx hx plus gx dx dhx as delta goes to 0. So if you multiply the functions together, two functions, then you first take a derivative of the first function and multiply the second function plus
first function times derivative of the second function. Probably you know this already from school, right? Perhaps you can take a break for 5 minutes and continue.
다른 게 아니고 지금 이제 그 플로리다 대학은 쓰시는 건가요?
네, 뺐어.
아 빼셨어요? 그럼 이거 제가 근데 한글 파일 그 워드 파일이 없어가지고
1 이해해야 되는데.
네 2로 고칠 거 지금 체크해놨습니다. 그리고 그 뒤쪽에는 QEM 그거 그 이렇게 약자로 쓰셨었잖아요. 근데 앱스트랙에는 QEM 자주 나오는데 이거를 어떻게 할지. 네. 그리고 여기 좀 자주 나오더라고요.
앱스트랙트 QEM을 해야 되겠네.
여기 QEM을 하고 이제 뒤쪽에 QEM으로 바꿔야 될 것 같아요. 그리고 여기 인트로덕션에서 QEM이 앞쪽에 먼저 나오거든요. 근데 뒤쪽에 한번 쓰셔가지고
이거 바꿔야
네,
되겠구나.
이거 바꿔야 될 것 같고 그리고 이거
대문자로 되네.
아 이거요? 처음 나올 때는 대문자로 하실 건지 교수님께서 네, 판단하시면 될 것 같습니다. 그리고 여기는 에러 미티게이션인데 이거 그냥 퀀텀 에러 미티게이션으로 해야 될지.
그렇지.
네, 여기도 뒤쪽에 이런 식으로 좀 나오긴 하거든요. 여기 뒤에 이제 여기 QEM 하시고 아마 다 바꾸셔야 될 것 같습니다.
오케이.
네, 여기도 한번 다시 나오고요. 여기도 이것도 교수님께서 아마 판단을 해주셔야 될 것
다 해야
같은데.
되겠네.
네, 거기 일단 체크는 해놨거든요.
어.
이렇게 해놨고 그리고 여기 그 아이온큐가 대문자로 쓸 때도 있고 소문자로 쓸 때도 있어서 다 대문자로 아마 바꾸셔야 될 것 같은데.
오케이.
근데 그 사이언티픽 리포트는 조금 애매한 게 거기 IBM 통일하라고 했잖아요. 근데 제가 IBM으로 쓴 건 다 대문자로 썼는데 그 기기는 원래 소문자로 쓸 때가
소문자로
있거든요.
써야 되는 거야 원래.
네, 근데 거기서 통일을 하라고 해가지고 사이언티픽 그 레프리가.
소문자로 하는 게 맞지.
네, 근데 이게 IBM 그냥 회사로 쓸 때도 대문자로 쓰잖아요.
IBM 퇴사를 쓰는 대문자 써야지.
네, 근데 그거를 지적을 한 것 같더라고요. 그래서 근데 다른 논문들 찾아보니까 그냥 기기도 다 대문자로 쓴 게 있어가지고 사이언티픽 리포트는 다 대문자로 바꾸는 걸로 가는 게 어떨까.
오케이.
근데 여기는 아이온큐로 하면 이거 대문자 쓰셔야 될 것 같아요.
고칠 게 많네.
네, 여기 뒤에 QEN
다 고쳐야 되고.
네, 여기 다 체크는 해놨고요. 그리고 니스크는 앞에서 한번 정의를 했었어가지고
써야 되는
여기서
거지.
니스크로 쓰셔야 될 것 같습니다.
오케이.
네, QEM 드리고
예.
네, 그리고 여기 뒤쪽에 레퍼런스에
일렉트론 그건 고쳤어.
네, 그리고
3번도 틀렸어.
네, 여기 뒤쪽 3번이
아니 위에 13번인가?
13번이요?
11번. 캐노니컬.
이거 제가 못 봤네요.
내용은 어떤 거 같니?
내용은 좀 완성도가 있어진 것 같습니다. 그 뒤쪽에 적어 두셨잖아요. 코스트 넣으셨잖아요.
코스트 펑션 하나 넣어서 좀 좋아졌나?
네, 그런데 아무래도 이제 제목이 이렇게 되다 보니까 그게 필요했던 것 같긴 합니다.
코스트 펑션 제목을 넣는 게 낫겠냐, 안 넣는 게 낫겠니?
코스트 펑션이요? 저는 이게 딱 심플해서 더 좋은 것 같거든요.
그치, 어차피 NPJ에 될까? 던져볼까 한번?
네, 괜찮을 것 같아요.
NPJ에 던져보고 만약에 사이언티픽 리포트로 보내라고 할 것 같아.
사례로요? 근데 사례보단 딴 데 보내시는 게 좋지 않을까요?
쿼텀 사이언스 테크놀로지 같은데.
네, 그런 데나 뭐 EPJ 뭐 퀀텀 뭐 그런 데도 있더라고요. 네, 그럼 여기 피규어에도 아마 이 QEM으로 쓰시는 게
피규어는 약세 쓰지 말래.
아 그러면 이거
퀀텀을
지워놓겠습니다.
써야 되겠구나.
아 그럼 이거 체크는 해놓겠습니다. 아 이거는 그럼 지워놓겠습니다. 그리고 그 뒤쪽에 이거는 제가 여기 아이온 큐 하나 있었고요. 그리고 다른 거 괜찮은데 여기 이거 포맷을 네 이거 포맷을 제가 다시 바꿔서 보내드리겠습니다. 이거 저걸로 이거 이게 글자 누워놓은 게 저는 이거를 해놨었거든요. 네 이거는 그냥 세워놓고
원래 그렇게 알아서 해야 돼. 알아서 보내볼게 그냥.
아 네 알겠습니다.
그것만 보내줘. 색깔 변한 것만.
아 네. 그리고 이게 하나 여기 레퍼런스 마지막에 책 이거 있잖아요. 근데 저는 이거 MPJ 포맷에 일단 이거 도시가 없어서 여기다 빼놓긴 했었거든요.
오케이.
근데 둘 다 넣으셔도 괜찮을 것 같습니다. 이 파일을 그러면 보내드릴게요.
내용은 좀 좋아진 것 같아?
네. 좀 더 뒤로 보내는 게 좀 깔끔해진 것 같아요.
그렇지. 서플멘트에 다 넣어놓으니까 그냥
네.
그거 하나가 논문 같잖아 그냥.
네. 실험 결과도 사실 다 필요한 것 같지는 않아가지고.
사실 그 리얼 KT 하나만 있으면 되니까.
네. 그리고 이것도 넣으신 것도 괜찮은 것 같아요.
이게 구하기 되게 쉽더라고. 앞에 그 뭐지?
역추적하신 거죠 이 결과도.
그러니까 그 앞에 본문에서 보면은 이제 리볼루션 오퍼레이션 매트릭스 쓸 수 있잖아.
네.
이거 인버스 구하면은
이게 포스트 펑션.
거기에. 그건 원래 이제 한 거고. 그 인버스를 구하면 되는 것 같더라고. 그래서 이거
근데 이거 약간 숫자 수식도 크기가 조금 달라 보이는데 이런 건 괜찮겠죠?
이거 안 살 거야.
제가 이거 다시 한번 확인해보고 다시 카톡으로 보내드리겠습니다.
오케이. 유학년 미적분에서 이런 거 다 유효해요? Okay. Another case is composite function. So derivative of composite function. So f x plus delta minus fx 3 hx plus delta minus 3 hx. So here we assume that hx plus delta can be written as hx plus delta h as delta goes to 0 and delta h goes to 0. Then delta divided by f plus delta minus fx is delta over 3 hx plus delta h minus 3 hx. At this point, we can do nothing. We do nothing. That is, you divide by delta h. delta H is actually Hx, right? As delta goes to 0, both delta and delta H goes to 0. So this becomes dH gh times dx dH as delta goes to 0 and delta H goes to 0. This is called the chain rule. So dx d g hx, you first take a derivative of dgh as h as an independent variable, and then dx dh. This has a name called the chain rule. So this property is probably the most important derivative that you are going to need for this semester. You probably learned this chain rule in your freshman calculus, right? This is a bit difficult concept, but so example, fx 1 over cosine x. So you can regard hx as cosine x. Then this is hx, right? So this is f hx. Dx d f hx dh d 1 over hx times dx dhx, right? dx d cosine x is minus sine x minus cosine 제곱 x minus sine x. This is cosine x, sine x, cosine x, right? And we define tangent x as sine x divided by cosine x, secant x as 1 over cosine x. So this is tangent x, secant x.
If you just follow the rule for the composite function derivative, when f is 1 over cosine x, you regard cosine x as some function h. And 1 over h, if you differentiate 1 over h, you first differentiate with respect to h first. And then you take derivative of h. So 1 over hx is minus 1 h squared.
Because we know that dx x is minus x squared, right? So you use this property here.
You just take h as just an independent variable. Then 1 over h, if you differentiate by h, minus 1 over h squared.
I didn't bring the pointer, otherwise, check. Unfortunately, I don't have a pointer with me. That's okay, I guess. So, we have the following. dx secant x is tangent x secant x. This is one derivative. How about tangent, for example? fx tangent x. This is sine x cosine x, right? It's actually sine x times secant x.
So this is a product of two functions, right? So you can also utilize the formula for the differentiation of the product of functions. So dxt tangent x is, you first take the derivative of sine x and secant x, right? Plus sine x dxt secant x. dxt sine x is cosine x, right? Cosine x. Secant x is 1 over cosine x. Sine x. If we differentiate the secant x, we already have done that before, right? So that is tangent x secant x. So that is 1 plus sine x times sine x divided by cosine x by cosine x. 1 plus cosine square x sine square x is
cosine square x plus sine square x, right? But this turns out to be equal to 1. So this is secant square x. Previously, we have taken this dx secant x is tangent x secant x, right? This is a very interesting derivative, so I like to spend some more time with this. So, okay, we have tangent x secant square x, right? And dxt secant x tangent x secant x. What happens if we add them together? dxt tangent x plus secant x secant square x plus tangent x secant x, right? Secant x plus tangent x. If we divide by everything by secant x plus tangent x, what do you get? One over secant x plus tangent x dxt tangent x plus secant x secant x. What about this log fx? Or you can say just ln, same as. I can use either log or ln for natural log. So this is a composite function, right? So this is basically, you can write down as df d log f dx df, right? So what is the log f? If we take a derivative, 1 over f, right? So 1 over f dx df, same as dx d log fx. So this part actually turns out to be what? This is the same as dxt log tangent x plus secant x. This particular derivative is called logarithmic derivative. I think we covered almost every function except the hyperbolic function. So maybe it would be beneficial for you to give some homework that you can do some exercise. So secant square x, secant x is this, right? We know that homework. Find the derivative of cotangent x, cosecant x, inverse cosine x, inverse tangent x. Wouldn't hurt. Maybe one more function, hyperbolic function. Cosine hyperbolic x is defined as exponential x plus exponential minus x. Sine hyperbolic x, exponential x minus exponential minus x. We have done that dx, d exponential x is exponential x, right? How about dx, d exponential minus x? This is basically is a composite function, right? So minus x as h. Then this is same as dh, d exponential h times dx, dh minus exponential minus x, right? So therefore, dx, d cosine hyperbolic x is ex minus e minus x is sine hyperbolic x. dx, d sine hyperbolic x exponential x plus exponential minus x cosine hyperbolic x. So maybe a few more homework. There is one particular function that, so just do do some homework for trigonometric functions, inverse functions, and hyperbolic functions. Tangent hyperbolic x, cotangent hyperbolic x, secant hyperbolic x, cosecant hyperbolic x. Maybe inverse sine hyperbolic x. Inverse cosine hyperbolic x. It's probably this homework will get you familiar with all the derivatives of different functions. So I think we covered basically what you need to know about derivative and integration. The integration is actually inverse of a derivative. So integration is inverse of a derivative, and that's actually definite integral. Indefinite integral is some constant. It's called indefinite integral. As a matter of fact, the theory of integration is a topic that at least you need one semester to get into details in analysis course. But this is mainly for application, so I just will cover basically what you need to do. These two things you need to know. The main topic, differential equation. Some homeworks, right? Okay, I'll just let you. and equations containing derivatives. So 80% of engineering problems are related to the differential equations, and you can convert most of the into AX equals B4 linear algebra problems. So if you're an engineer, then you need to know what is the differential equations, how to solve those equations. Luckily, you can convert those differential equations into the matrix forms. So that's the reason why I spend more time of our first time for the linear algebra that equals that here is the matrix algebra. So 70 to 80% of the engineering problems that will be eventually related to the matrix. So these two topics are probably the most important topics as an engineer. So let's try to do some simple example. We are trying to find some function which yields cosine x when you differentiate. It's easy, right? So fx sine x plus some constant. How about this is a bit complicated, right? Or can you find any function when you take a derivative, give a sequence x, 1 over cosine x? We have some approximation. One is dxt, sequence x is what? Tangent x is sequence x, right? dxt tangent x 1 plus sequence x. Let me check. Right? So it's not an easy problem to solve. So what do you do? This is a very difficult problem, right? for some simpler form. I give and logarithm. Okay, so I'll just or some simpler form. dx dy secant x.
Is there any way that you can find the origin function when you differentiate it, you will see concept? We have some clue.
We know that we have 1 over tangent x secant x dx tangent x secant x is same as dx log tangent x plus secant x is secant x, right?
We have to know this logarithmic derivative, which gives secant x.
So we can solve this equation, right? The answer is this. Y must be something like log tangent x plus secant x plus some constant.
So that gives you some idea for next week's quiz, right? Definitely, I might ask you to solve this kind of equation, which is the result of a logarithmic derivative.
So at this point, I'll give you another homework. Maybe find 10 maybe you can ask Google or ChatGPT.
So I would ask ChatGPT, find most common 10 logarithmic derivatives. You can do that, right? ChatGPT 3, 3.5, 4? It doesn't matter.
Ask the particular word most common as a keyword.
So 10, find the 10 most common logarithmic derivatives. And work out.
And including this, so actually you need to work out 11 because tangent x plus secant x is one of the typical
Logarithmic derivatives. So before actually trying to solve differential equations, let's start with this logarithmic derivative problem. Probably it's better to stop today because if I continue, then you have more material to cover for the next quiz, right? So just make sure that before I close this class derivatives, and of course, some parts of the linear algebra that I didn't cover in the last case will be also subject, such as polar decomposition and principal X theorem, and some of the eigenvalue problems. So I think the importance is about half and half. So half of the problems from linear algebra and half of the problems from calculus is the subject of next quiz. So if you successfully go through the quiz, then we have a really good qualification and background to cover the next topic. So I wish you good luck with your next quiz, and probably I'll start today. And before I finish, any questions? You can either ask in English or in Korean. Make sure you prepare 2 pages of filling sheet every 2 hours. Okay. 7 is it. I will upload my class probably tonight.